So hi everyone, welcome back to Invino. This is the example 3 of the same pack under the topic of recurrence. And this question is slightly more challenging than the previous two because this question didn't give you what you need to prove for the recurrence relation, and we have to prove it ourselves. But probably if you have already watched the previous two examples, example 1, example 2, then probably should be having no problem. So the question is said, find a recurrence relation of the IN integrating from 0 to 1, x and over x squared plus 1 squared dx. I think that the question should specify that for easier calculation, the n should be starting from 0 and up to infinity. And then this one should be too hard. If you have watched my first example, then we just simply need to apply the standard integration by part, which we split the IN into integration from 0 to 1, and then x n minus 1 times x over x squared plus 1 squared dx. So let me highlight it, which is xn split it into xn minus 1 and x. And then we do integration by part. We put u as xn minus 1, and then we put the v as x over x squared plus 1 squared dx. Just the same, so the u will be power root n minus 1, and then x n minus 2 dx. V will be integration of the x squared plus 1 squared dx. And then, of course, for the right-hand side of this part, some students may get stuck, but if you still remember this part, we can actually use u substitution again. U substitution. We put another u. Remember, they're just a dummy, and that's why this green u is different from the red u. So u equals x squared plus 1. And then du is actually just 2x dx. And that's why v will be integration of what? Integration of, because x dx is just simply du over 2, du over 2. So that means this one will be just simply u negative 2 and then du over 2. And therefore the v, I can take the 1 over 2, and then I'm actually just integrating u to the power of negative 2, which is u to the power of negative 1 over negative 1. So v is just simply negative 1 over 2, and then x squared plus 1, negative 1. Okay, straightforward. And then the next step is that we can really apply the integration by part formula. Yes, so that means I write it here. In, standard integration by part, uv minus integration v du. And that's why in is, what is the u? The u is xn minus 1. Xn minus 1. And then times the v, which is negative 1 over 2, and then x squared plus 1, negative 1. So this time we're substituting from 0 to 1. From 0 to 1. And then minus, we integrate from 0 to 1, and then v du. So v is negative 1 over 2, and then x squared plus 1, negative 1 du. N minus 1, x n minus 2 dx. So far, so good. So for this one, this is in, and then if I do some simplification, so this is just negative 1 over 2. The numerator, I got xn minus 1 over x squared plus 1. Substituting from 0 to 1. here I got negative and negative, so I have positive here, positive. N minus 1, n minus 1, and then 2. Constant, I can take it out, so n minus 1 over 2, integration from 0 to 1, and the numerator got xn minus 2 over x squared plus 1 dx. Then this was just the green part. And now I can do the first part substitution first, so that we can simplify it a bit. The in equals negative 1/2. This is just simply 1 over 2 minus 0 plus n minus 1 over 2 integration from 0 to 1 x n minus 2 over x squared plus 1 dx. And that's why in is just simply negative 1 over 4 plus, let me be a little bit lazy, so I duplicate it, so this part is this guy. Okay, so if you have watched my example 2, the previous example, then probably you'll understand the next step is what? The next step is we have to observe what is the in. The in now is power 2, right, in the denominator. And that's why, as what we've mentioned in the example 2, we have to do some adjustment for the numerator as well. So that means that I want to change the denominator to square as well. So I will do something like this. In negative 1 over 4 plus n minus 1 over 2 integration from 0 to 1. So in order to change the denominator to square, then I have to multiply the additional x squared minus 1 to the numerator as well, in order to utilize the in given. So this is actually similar to the 2019 past paper question in example 2. And then the next step is just simple distribution. Then I will have in equals negative 1 over 4 plus the n minus 1 over 2, and an integration from 0 to 1. And then this one is xn minus 2 times x2 is just xn over, this is x squared plus 1 square dx, and then plus into missing the n minus 1 here, over 2 integration from 0 to 1, and then xn minus 2 over x squared plus 1 squared dx. So far so good, right? And that's why easy now. So this part is our in. And then this part will be our in minus 2, right? And that's why we can just simply solve the algebra, which is, this one is in plus n minus 1 over 2 in minus 2. So I didn't combine, like I didn't take out the n minus 1 over 2, because like at the end of the day we have to extract the in. So that means I want to multiply the whole equation by 4. So I will have 4 in equals negative 1 plus 2n minus 1 in plus 2 bracket n minus 1 in minus 2. And now we'll just simply group the like terms. So I have 4 in and then minus 2n minus 1 in equals negative 1 plus 2n minus 1 in minus 2. So here I take out the in, and that's why I have, I also take out the 2 maybe. Then I have, oh no, maybe I just simply combine it first. So this one is 4 minus 2n plus 2. Then this one will be negative 1 plus 2 bracket n minus 1 in minus 2. So this is in 6 minus 2n equals negative 1 plus 2n minus 1 in minus 2. And the final step will be just simply -1/6 minus 2m plus 2 bracket n minus 1/6 minus 2n in minus 2. If I want to make the answer more beautiful, then I can actually take out the n as well. Take out the 2 as well. -1/2 bracket 3 minus n plus 2 bracket n minus 1/2 bracket 3 minus n times in minus 2. And 2 and 2 cancel out, and that's why I can have in equals like -1/2 bracket 3 minus n plus n minus 1/3 minus n in minus 2. And there's some students, they want to strive for perfection, then you can further reverse the order of the 3 minus n, which you will have -1/2 bracket 3 minus n, and then you change this one to minus. And then this one will be n minus 1/n minus 3 in minus 2. And then done. That's it for example 3. So I think like if you have watched my previous 2 examples, then probably you won't find this question too difficult. And if you have any further questions, feel free to comment below, and I will see you guys next time. Thanks a lot.